unaware of just how we got
it all. Coach Jay, Study Session. Hope you're having a great day today. And man, I got a lot of energy tonight. I have no idea why. I've got my jam song going on. I've got my jam class AP stats. Let's get this rolling. We are going to get this show on the road right now. Hope you're having a great night tonight. About as good as I'm having. If you are, good for you. We have a lot of stuff to go through, a lot of things that are coming up on the horizon that I want to make sure we hit on. We got one FRQ that I'm going to focus in on today, and then we're going to go into some multiple choice. And once we finish that up, if you have some extra questions, come on, get some questions answered. We'll rock and roll. A couple things that I want to make sure I note is the FRQs before I get started. Make sure you know that there is probably going to be a proportion to mean, so be careful of that. Also, make sure you know type 1 and type 2 error. You want to make sure you know the difference between those two. That's a big deal. It's not a main part, but it is a part, so just make sure you understand that in the context of what we've talked about. Also, if you can't hear me, make sure you let me know, and I'll turn down some Z there, and we'll get underway. I'm going to pull up this chat. Again, if you have questions, you could either text me, go through mine, or through my phone, or you could simply put it in the chat. So I'm just going to say put your questions here. All right. So feel free, again, if you need some help on that, check it out, and we'll go through those questions together. So without further ado, hopefully we're not going to be jumping on any more counters. My wife's not here, so it's one of those things I'm able to do that today. Just don't tell her I did that, and everyone will be good. All right, let's start with it. This is the actually the last question within our practice test here. Again, if you turn that in tomorrow, we'll give you +3 on the test. Just a little incentive to do a little bit of extra work, a little extra practice. And here we go. All right. So again, when we go to this, these problems, especially with difference of proportions or means, we're trying to make sure that we look at specific words or terminology that stick out to us that identify what type of test that we're talking about. So as we look at 10.13, it says Pat wants to compare the cost of 1 and 2. Okay, that's a key. 1 and 2 bedroom apartments in the area of the college campus. Okay. She collects data for a random sample of 10 advertisements of each type. The table below shows the rents for the selected apartments. So we have sample 1 and sample 2. All right. So we'll label this 1 and we'll label this 2. Now it says Pat wonders if 2-bedroom apartments rent for significantly more on average than 1-bedroom apartments. Okay. That's a pretty good question. So the question is which would be more? So but she specifically says she wonders if, this is her alternative, the 2-bedroom rent for significantly more on average. So let's start off by, and yep, here's the hypothesis. So anytime we state hypothesis, let's talk about the test we're going to be doing. The hypothesis allows me to see that this is going to be some sort of test. The mean, not proportion, but the mean tells me that I'm going to be doing a z-test of some kind. And we understand that on our calculator, we'll be doing a 2-proportion z-test based upon, oh, I'm sorry, because it's mean. I said z, my fault. I meant t. My fault. This is me confusing you. Z is with proportion, right? And t is with mean, okay? So because it's with mean, we do a 2, and this is where I go off kilter here. A 2-sample t-test, okay? 2-sample t-test. If you want to, we can look at another one later. Again, let me make sure I reiterate that. I'm starting on a good note, right? My fault on that. We know it's a mean, so we're going to be doing a t something. We're talking about a test because we're looking at hypothesis or significance. And the reason why it's a 2-sample is because within our calculator, that's how we define it. So a 2-sample t-test is what we're doing, okay? Excuse me, sorry about that. So as we look at our hypothesis, we remember that the hypothesis is always that mu1 minus mu2 equals 0, especially when we have difference of 2. So let's have our state here on this side. Our null would be mu1 minus mu2 is equal to 0, whereas our alternative is going to say mu1 minus mu2. And this is where it becomes a little different. If the one bedroom is, we're trying to say, is less than the two bedrooms, then this value will be less than this value. So this will produce a value that is less than 0 because the 2 would be greater, right? So the less minus the greater. So we would say in this case that it is less than 0 is our alternative, okay? And it does say state an appropriate pair of hypothesis. Be sure to define any parameters you use. So that's one thing too, is making sure that mu1 and mu2 are defined, where mu1 would be the true mean price for one bedroom apartments. And I'll write it all out here. And then on the second one, a lot of times I'll say, okay, this is the true mean price for two bedroom, okay, apartment. So we've defined everything. This is our state part. We've done everything we needed to do by defining what mu1 and mu2 is. We have our null, we have our alternative. So we've got everything there for part A, or our state part. Part B states, name the appropriate test and show that the conditions for carrying the test out are met. So it's really just going down through a state, plan, do, and conclude down through here, okay? With the state being A. Now, the one thing that you don't see here is the fact that we do have a list 1 and list 2, but we don't know what X bar 1 is or X bar 2 is. S of 1 we need, and S of 2 we need. But we can do this by, we can find these things instead of just plugging it in into our calculator the long way. We can plug it into our calculator the short way. And so just to kind of give you a heads up of what that would look like, just in case, I'm going to come over here, and I also want to make sure that everyone's hearing me. All right, perfect. I think everyone's good. I think everyone's hearing me here. I'm not seeing anything on this, which is good news. All right, let's take a look at this. I want to share my calculator screen. And what we'll do is we'll stay here for just a second. So based on the previous information, what we want to do is take this information and go straight to our edit button. Okay. All right. And then you're going to go up, and a lot of times I press clear on the L1 and then come down, and that always clears the whole list. So come down. And so on my L1 list, I'm going to put the one bedroom stuff. So we're going to put 500, 650, 600, 505, 450, 550, 550, sorry, 550, 515, 495. Notice this is not a match pairs design, even though it has two lists, because we're not comparing the same individual to two separate conditions that we're putting on it or giving to it. That would be much different. So this one, again, just a heads up, this is much different than the other ones here. We're going to go to the second one, 595. We got 500. We got 580, 650. And again, a lot of you already know how to do this. And again, I know I'm going the long way. I don't even think you have to do this with this condition. But I know a lot of people were questioning, hey, coach, how do you find all this stuff? Just as a reminder, I wanted to make sure we go through all the calculator conditions here. So once I plug that in, I like to go to second quit to get out of there. And then I'm going to go back to our stat. And this time I'm going to go over to calculate with the one variable statistics. And simply, I'm just going to make sure that that is in the L1 there, okay? That L1 is listed. So in fact, it is. When I calculate it, I will find that my average is 531 and my S of X, which is 82.8, 82.79. So I'm going to write this down here. So X bar 1, S of 1. I'm writing this down. I know you're not seeing it fully behind me here, but I do want to make sure. 531 and 82.79. 82.79 and 531. Okay. So that's number 1. Let's look at X bar 2 and S of 2. Okay. So we're going to go now. The only difference with this one compared to the one we just did is it's a little different. And it's because I plugged in both values there for L1 and then L2. I can go to stat and then simply go to calculate again. Except now with the L1, I need to go to L2. So I need to go the blue 2 to get L2 there. And then once I calculate, I'll get 609, 89.3. 609 and 89.3. 609, 89.3. Okay. So I've got all of that. If I had to calculate it, I could in an easy way, in an easy format there. Okay. And then also I wanted to now take this and attack it this way. Let's say come back to my screen share here. All right, perfect. So now I've got my first and my second here. Now we're going to show the conditions for carrying out this test. Okay, so this was random. It was the fact that it was stated up above, a random sample stated as random. Okay. So because of that, we have that condition met. We then are going to ask about independent. I believe this one could go either way as far as independents go. The amount of one apartment, does that have any impact on the other one? Depending upon the area and that sort of thing, I guess there's a lot of factors that could contribute to that. So just in case, I probably would give it to you if you said these are independent events. But just in case, let's make sure by doing our condition of n is less than or equal to 1/10 of big N, right? And we really have 2 of these that are shown. We have 3, 6, 9, 10 of these. So 10 is less than or equal to 1/10 of my population. And this is true, and I would just say it's true for 1 and 2 bedroom apartments, okay? So that would be true for independents. And then the last thing we need to look at is normal, which states that our n, little n, is greater than or equal to 30. We're going to have to show this twice. I don't think, 2-bedroom. I'm looking and seeing if they say anything about the normal condition. I want to compare the cost and area. State of 10% tables below shows the rents for the select apartment. So since n is not greater than or equal to 30, in this context, this is not true. What we have to do now is go and see, well, first off, the population, it didn't say anything about the population. So what we've got to do is just simply throw something down that basically says, okay, if I were to graph this, which this goes in a lot more depth than what they're looking to for this specific problem. However, for this one, if I were to say, okay, 1 bedroom, how many, okay, what do we have? We have 1, and I'll just do the 1 bedroom just so that you know what it looks like. So if I say this is from 3 to 350, right? To 400 to 450, okay? This is a 500, 550, 600, okay? 600's here. And so what you could do is basically say, okay, how many values are between 3 to 350? I had none, right? How many are from 350 to 400? I had 1, I believe, right here, right? How many from 4 to 450? I had 1. Okay, perfect. Next one I would have would be 495. Okay, actually I would have 2 here because I missed 1. I'm sorry. This would actually be 2 here. Okay. How about from, oh, I'm sorry, that wouldn't be because this would just be 1. This is from 450 to 500. So it should be, we'll just say this is 1 right here. Okay. 1 right here. From 5 to 550, we would have 1, 2, 3, 3. Okay, so this would be higher. And then I would keep going. But basically what I'm looking for is something that says, once I've graphed I went into more detail than what it should have. But I would say no outliers or extreme. And I would say no extreme outliers or skew data. Okay. Therefore, because of that, we're going to approximate with normality. Okay. Now, I want you to take just a screenshot of that or just a mental image of that, because we're going to come back to that here in a second. Specifically, this part right here, the 531 and that sort of thing. And in fact, I'll try to leave that. The next part says, one thing I want to do is just basically show you how I find my test, how I use my test to find the p-value there. And I know this is going a little bit in depth, but I think it's helpful for just all different parts of things that we could face on the test here. So let's see if we can pull this up. Again, remember, this is a 2 sample t-test is what we're looking for. So when we go to our stat, we're going to go to our tests on the far right, and we're going to go into a 2 sample t-test and press enter. Now on this one, just like we had before, we are going to just plug in the information that we know. So we already know that, and I'm going to pull this over here. Good. Okay. So the first one had 531 as its mean. The S of X was 82.79, and N was 10. Okay. The second one was 609 for the 2-bedroom with a standard deviation of 89.3, and with 10 as N. And because of the fact that we are looking at something that is less than, right, where the second one is greater than the first. And remember, we never use pooled. The only time we use pooled is within our Z, when we're doing our Z test, okay? The only time we're doing that is with our 2 proportion Z test. That's the only time we pool it. Sorry, getting some water. So once we find this, we just simply press our enter button. Make sure we go down, and we can draw it if we want to even give ourselves a little picture, and it will graph it here. Should give us the value of the p that they gave us. I think was it 0.02. So here's the picture. Again, it is less than. Notice the left side was shaded. That's important there. And 0.029 was in fact what the p-value that they gave us there. Okay. They also did not give us the degrees of freedom. You could find that, I believe, if you, instead of doing the drawing, you went back and just did the calculate. I think they gave you that degrees of freedom on that. In fact, I know they do. They'll give you that degrees of freedom there. So now the question is the appropriate test, interpret this p-value. Okay, remember the p-value is assuming the null is true. And I'll come back to context is in a second. Assuming the null is true, p-value is the probability our sample, since we did a difference, our sample difference occurred purely by chance. Now, this was a, as you say, like a broad definition. If I was trying to kind of condense it down, I would say, assuming that 1-bedroom and 2-bedroom apartments have the same price, we can assume that the p-value in this context is the probability of our sample difference of our second bedroom minus our first bedroom occurring purely by chance based upon the sample that we obtained here. And so remember that if this, in this context, if this p-value is less than our significance level, we say that that occurrence by chance is small enough to say that we are able to reject the null hypothesis. So on D, coming back to D here, It says, what conclusion should Pat draw at the 0.05 significance level? We would say because P is equal to 0.029 and it is less than 0.05, which is our Jesus fish or our significance level. We have convincing evidence to reject the null, which states that there is no difference. And this is where we put context here. In this context, we'd say that there was no difference between 1-bedroom and 2-bedroom prices. You could even put something that accepts the alternative. That would be okay there too, saying that the 2-bedroom prices are higher than the 1-bedroom. Okay. Wow, that was a doozy, but I hope that that was helpful. We will go from there. My wife just came in with Starbucks. She is awesome. Right there. She says, hey. Holla. That's right. All right. So, did you just say holla? I never say uncool things in class. Forgot. What did I say today? And while we're going to this next problem. Forgot. I said something like vaguing. Vaguing. Vaguing's a word. Vaguing is a word. All right. I made kind of it up. There. There's a lot of words that I made. There's one today that someone looked at me like I had 2 heads on. I'm not like the hip teacher anymore. If I ever was the hip teacher. I don't know if I've ever was the hip teacher. I was like, I just passed the cool phase. All right. So where were we? Yes, math, AP stats. Let's get it going. I have not checked my chat here in a while. Let me see what my chat says. Ooh, no questions. Well, that's great. I've got 3 viewers. Well, that's I am popular tonight. This is good. Yes, this is true. This is true. I am literally rubbing off on my wife right now. Although Sarah, you did sing in class today. That was kind of, that really surprised me. I'll be honest. That surprised me today. All right, 10 questions. Here we go. We're going to go through these multiple choice. We're going to try to navigate these together. And if you do have questions, let me know, and we'll go step by step through them. All right, 10.1. A study of road rage asked separate random samples of 596 men and 523 women. You get a different marker here. There we go. And it says about their behavior while driving. Based on their answers, each respondent was assigned a road rage score on a scale of 0 to 20. Are the conditions for performing a 2-sample t-test satisfied? Well, remember the conditions that we need would be the plan phase. Those conditions mean normal, right? Is n greater than or equal to 30 for both? Is it independent? I would say this is an independent event. That would be me. That's what I would say here. Also, I think this is greater than or equal to 30. Yeah, so we've got it here. These are independent events, so we're good here. And then is it random? So how did they select it? A study of road rage asked separate random samples. And I think we've got that there. Now, let's just make sure that the 2-sample t-test is satisfied. Okay. All right, so I think we've got that there. What are they saying? Are they saying that the null of mu1, which is the average response of women minus men, would be 0, and the alternative would be greater than, less than, or not equal to? I'm guessing that's what they're looking for, okay? All right, let's see. A says maybe we have independent random samples, but we need to look at the data to check normality. Okay, that's not true because it's greater than or equal to 30. Did it say anything about population being normal? I don't think so, so we're good there. No road rage scores in range between 0 and 20 can't be normal. Okay, that's not true. We don't know the population standard deviation. We don't have to know that, right? Because remember, we approximate it with S of X, and that's why we use T instead of Z within our, when we talk about mu, right? Or mean. Yes, the large sample sizes guarantee that the corresponding population distributions will be normal. Okay, I don't know if it guarantees it. We're heading in the right direction. We know it's a yes, but let's look at E. Yes, we have 2 independent random samples and large sample sizes. I like this answer. This guarantee mess over here. We approximate it because we can approximate it as normal because of the large sample size, but we can't guarantee it. And so because of that, we're just gonna leave it, and we're gonna say that it's E there. E is our final answer. All right. 10.2. 35 people from a random sample of 125 workers. So 35 out of 125. Workers from company A admitted to using sick leave when they weren't really ill. 17 employees from a random sample of 68 workers from company B, this is A, this is B, admitted that they had used sick leave when they weren't ill. A 95% confidence interval for the difference in the proportion of workers at the two companies who admit to using sick leave when they weren't ill is what? Okay. So the question that becomes in front of us is what formula do we use? Well, we know that the 35 divided by 125, I'm going to get this value here. I'm guessing that when I do A minus B, the like P hat 1, we'll say, and P hat 2, that when we subtract these, we're going to get 0.03, right? Because you could kind of see that there. So we got those 4 values here. Remember, though, with this formula, it's P hat 1 minus P hat 2. That is our estimate, plus or minus Z star. And this, again, is on your formula sheet. You could kind of take a look at. And then it's the square root of P hat 1 times 1 minus P hat 1 divided by N1. And then plus P hat 2 times 1 minus P hat 2 divided by N2. Okay? Well, N1 is 125. Okay? N2 is 68, which I don't think changes from any of these here. The 95% confidence interval tells me that my Z star is going to be 1.96. Okay. 1.96 is our Z star here. So we've got, really we're boiled it down because this doesn't have a Z star. So this one's gone like a freight train, going like yesterday. This one's gone like a soldier in the Civil War, bang, bang. And this one's gone like a 59 Cadillac. All right. So now we've got either B or D. So the question is in this context, do we pool the data? Okay, do you see it here? Because right here, this is pooled because you see the same values. Or do we not pool the data? The only time that I pool data where I use this thing called P of C, which really only comes into play in multiple choice. You don't have to show it on an FRQ. When I have pooled data, this PC only comes up when I have a Z test. So it's actually a 2 proportion. My fault, I should say. 2 proportion Z test. This is the only time that in this context you're going to pool the data together. So if it was just the 2 proportion Z test for standard deviation, it would be this one. But because of the fact that it is an interval, the only one that would be left over would be the answer of B. Okay? All right, very nice. We've got 2 for 2 today. 2 for 2. See how, all right, a lot of questions. Really no questions here. Any questions at all? Hopefully those are still coming up. Let's go to number 3. Number 3 says the power takeoff driveline on tractors used in agriculture is a potentially serious hazard to operators of farm equipment. All right, it's covered by shield. All right. All right, so we have 2 types of shields, bolt-on and flip-up. It was believed that the bolt-on shield was perceived as a nuisance, but the flip-up shield is easily lifted for inspection and maintenance and may be left in place. In a study, all right, here we go. A random sample of older tractors with both types of shields were taken to see what proportion of shields were removed. Of 183 tractors designed to have a bolt-on shields, 35 had been removed. So 35 out of 183, this one's the bolt ones, okay? Of the 136 tractors, 15 were removed. So this is the flip up, okay? All right, so we've got the 2. We've got a test. We've got our null. We've got our alternative where they're equal for my null, and the P of B is greater than my P of T. So the bolt is greater than the flip up, okay? So we're saying that my alternative is the probability of the bolt minus the probability of the flip is greater than 0. Or you could just say that this would be, if I added both sides, P of B is greater than P of A. Okay, so the question is which of the following is not a condition for after all this? Wow. Okay. Note to self, you might want to read what they're asking you before you write all this stuff down, because all they're wanting us to know is which of the following is not a condition for performing a SIG test, okay? Both populations are normally distributed. That is a must, okay? All right, so which of the following is not? So this one is canceled. That has to be. 2, that the data come from 2 independent samples. That's a must, right? Well, technically, it could, I mean, this is true, the 10% condition, if they aren't independent, but we'll come back to that here in a second, right? C, both samples were chosen at random. That's got to be a must. D, the counts of successes and failures are large enough to use normal calculations. Because this is a proportion, we must say that, oh, you know what I did? You know what I did here? Let me do this. Let me go back here. Let me backtrack because I think I'm messed up. Let's go backwards because I think you'll see why I did that here in a second. Both populations are at least 10 times the corresponding sample sizes. Population are at least 10 times the yeah, this is the 10% condition, right? All right, so that's a must. The counts of successes and failures are large enough to use, yep, because that's n times p is greater than or equal to 10, n times 1 minus p, which is failure, greater than or equal to 10. All right, so that's a must. C says both samples were chosen. That's got to be a must. Independence a must. This is not a must. Remember, this comes from the fact that the populations are normally distributed, comes from my mu, right? So because it's related with mu and not to proportion, this is only a condition. A is only a condition for mean rather than for proportions, okay? All right, 10.4. Quiz question gives random samples of 10 observations from each of 2 normally distributed populations. Tom uses a table of T distribution. So we've got 2, right? N equals 10. Both are normal. Tom uses a table of T distribution, critical values, and 9 degrees of freedom. Okay, so he's looking at T9. This is Tom. Hi, Tom. Everyone say hi, Tom. Hi, Tom. Okay, very good. He's saying this, that we're trying to find a 95% confidence interval for the difference in 2 population means, okay? So we subtract them. Population means would be mu1 minus mu2. We're looking for 95% confidence. So what is the 95% level where the true mu1 minus mu2 is, we are 95% sure that the difference of mu1 minus mu2 is between the lower to upper bound. That's this area, right? The second one, a little bit different here, says it's Janelle. Everyone say hi, Janelle. Hi, Janelle. All right. We are going to then say, all right, it has a 16.87 degree. Okay. So we're looking at our T of 16.87. And we are trying to compute the 95% confidence interval. Assume that both students calculate the intervals correctly. So everything's the same other than this right here, which is also, we don't need to know how we found it. We just need to know that it's affected by, hold up real quick. I want to make sure Tom uses a table, 10 observations from each of 2. Oh, and the 2 population means, okay, from what was on top. Okay, Janelle just did it a little bit. She uses her calculator. I want to make sure real quick. I want to make sure I see this right. With, okay, 60.87. Assume that both students calculate the intervals correctly. Which of the following is true? Okay, so remember that the higher the degrees of freedom, the higher this curve becomes. So, like if this is a normal curve, right? And that's an awful normal curve. A T curve with a higher degrees of freedom doesn't quite get to the normal curve, but it gets closer and closer. So the lower the degrees of freedom, the more area in the tail. So because of that, there's going to be this interval, which is at the 95%, with everything else being equal, will have a higher area up on top. But think of this as being like stretched upward. So because of that, that's going to pull in the lower and upper bound. And as a result, Tom's confidence, Janelle's is going to be much shorter, and Tom's confidence is going to be wider. So because of that, Tom's confidence interval is wider. That's why A would be the correct answer for number 4. Remember, the more degrees of freedom, the closer it gets to approximating to that normal distribution there. All right, let's keep kicking here. This says a researcher wished to compare the average amount of time spent in extracurricular. He obtained a random sample of 60 spent in extra for each speed. So spent okay, so 6 hours is the x bar here, and the S of x is 3. The researcher also obtained an independent SRS of 40 high school students in a large city, so different, right? We have 40 as my SRS here. And in this context, we have our x bar as 5 with 2 as my S of x. This would be 2, x bar 2, 1, and 1. Okay. Based upon this, what would be the z-score, the correct test statistic that's here? Well, remember that this is a statistic minus my parameter divided by my standard deviation. The one thing to remember is that what is the statistic? Well, in this context, they said it's the mu of suburban. So we're talking mu of S, we'll say, minus the mu of the city equals 0. I just subtracted this over, okay? So you could see that. So this is the null hypothesis. We're saying that there is no difference between those that are in the city and those that are in the suburbs. And so because of that, we will say that this is what we are deeming our parameter to be, right? We're assuming that to be true. So that's why 0 is the part that follows in each of these categories. So it doesn't eliminate A, B, C, D, or E. The next part is, how do I find my statistic? Well, our statistic is found by doing x bar S minus x bar C. Notice the correlation up here. So the S would be 6 minus 5. So we should have 6 minus 5 in all these, and we sure do. Good, good, good. Okay? Because we're talking about mean here, talking about mu, are we using Z or T? Well, in this context, mu only refers to the T, not Z. Z is proportion. So anything that deals with Z, we're going to get rid of and throw out there. So we've got these few left. And now, in order to solve for the bottom, we've got to remember that, or just find on our formula sheet, that the formula for this would be S of 1 squared over N1 plus S of 2 squared over N2. And this is also on your formula sheet. You might want to just kind of take a look at. So S of 1 would be 3 squared, boom, divided by 60, plus 2 squared divided by 40. Yeah, this answer should be E. Okay. All right. The next one says the p-value for the test is 0.048. A correct conclusion is, well, this is just shy of our traditional sig level of 0.05. So because it's less than 0.05, we can reject at the 0.05 level. So we can, let's see if we have anything reject at the 0.05 level. So that's one of them. Reject at the 0.05 level. That's one of them. Anything that says fail to reject at the 0.05 level, that one gets gone. Fail to reject at the 0.05 level. Good. Reject it. Fail to reject. No, this is rejected because it is less than 0.05, right? That's very important. Now, it says this, there is not convincing evidence of a difference in the average time. Well, the fact that we reject means that we do have there's convincing evidence of a difference because of the fact that 0.04, that's what rejecting means, that there is convincing evidence to reject the null hypothesis. And that's why on this one, number 6 would be E. Number 6 would be E here. Number 7, we're just moving right along. We're going a little quicker than normal here. Hopefully not going too fast here. I don't see any questions, and I still have 2 viewers, and I think one of them's me, but that's okay. No judgment. Okay. At a baseball game, 42 of 65 randomly selected people on an iPad, okay? 42 of 65, probably going to be a P-hat one of some kind. At a rock concert, 34 out of 52 own an iPad. Okay, so we've got that there. A researcher wants to test the claim that the proportion of iPod owners at the 2 venues is different. So we're just looking, so we're saying P1 minus P2 is equal to 0. That is our null hypothesis. Our alternative hypothesis, when they say that they're different, we're going to say that it's not equal to 0. Okay, that's how we would denote that there. To test the claim, the proportion of iPod owners at the 2 venues is different. A 90% confidence interval, so it's actually not even a SIG test, but if we were, we have it prepared. Or the difference in population proportion is, I want to make sure let me back up here. I want to make sure you can see that. Okay, so this confidence interval is as follows here and here, okay? Now, because it's at a 90% confidence interval, all right, remember that the Fishy that we're looking at, or the SIG level, is 0.01, is related to what is in here. So the confidence interval would be 0.154, comma 0.138. So the question is this significant to say that there is a difference? Well, notice that 0 does not, which is what we expected, right? So this is the fact that P1 minus P2 is equal to 0. This is this is what we assume to be true until we counter it. 0 is not in between my 90%. It's actually falling outside of this and this. So because it falls outside of this, we are able to reject this at the 0.1 level. Remember, 90% relates to 0.1 as our SIG level, okay? So just again, a heads up on that, okay? So because it's outside, we're going to say that we reject it. Well, let's see what happens. It says, because the confidence interval includes 0, the researcher can conclude, oh, hold up, it does. This is a negative. My fault. This is a negative. So because the confidence interval includes 0, the researcher, that would be the counter. The researcher can conclude that the proportion of iPod owners at the 2 venues is the same. I'm going to come back to that one largely because it sounds good. I can't assume that it's the same. It just means that there's insufficient evidence to reject the null hypothesis. Remember, we're assuming it to be true. But because 0 does fall in between, I didn't see that negative up there. We can't assume. Well, let's keep going, okay? B says because the center of the interval is negative 0.008, the researcher can conclude, no, okay, that's not true, okay? If you have 1 plus and 1 negative, that just because one's more one way than the other means nothing, okay? So be careful on that. C says because the confidence interval includes 0, the researcher cannot conclude that the proportion of iPod owners at the 2 venues is different. That is C, because that would be like saying that there's insufficient evidence, okay? So in this one, there is insufficient evidence to say, because 0's in between the 90% confidence interval, there's insufficient evidence to say that the iPod owners change whether it's at a baseball game or a rock concert. 10.8, SRS of size 100 is taken from a population A from a proportion with proportion of 0.8 of successes. All right, so one thing that I would just kind of caution you on is we have two independent, right? We have A and we have B. We know that something X, we'll call it, out of 100 equals a proportion of 0.8, which just means that X is 80, right? So 80 out of 100, whereas the second one has 400 and it's half, so we'd have 200 out of 400. You might say, Coach, why is that important? Well, it's very important because as we look at this, it says the sampling distribution for the difference in sample proportion has what mean and standard deviation? Well, this right here can be found by just plugging it into you could plug it into your calculator and get out exactly, if you go to the calculate button, exactly what your output would be there. The mean would be 0.3 because it's 0.8 minus 0.5. And so we see that there. If for some reason the standard deviation gives you fits on your calculator, again, you're going to, because we're talking about proportions and we're talking difference of two proportions, this would be a Z because of the proportion side. So, and I guess I was trying to think, because this is not really a test per se, is it? It's not really a confidence interval. I don't think it would give it to you out. I think you would have to do it the long way, wouldn't you? So the mean would be here. Let me do this out just so you know what's going on here. We're not going to pull this together, but the standard deviation would be the square root of p hat 1 times 1 minus p hat 1 divided by n1 from this information up here plus p hat 2. So I wouldn't even have to solve for that 200 or 80, but that's okay. 1 minus p hat 2 divided by n2. And then once I plug this value in, I should get, I think it's C, which is 0.047 there. All right, let's go to our last two. I know I'm going quick. It's been a long study session, so I want to make sure I finish up. It says, how much more effective is exercise and drug treatment than drug treatment alone at reducing the heart rate of heart attacks among men ages 65 and older? To find out, they performed a completely randomized experiment involving 1,000 healthy males. Half of the subjects were assigned to receive drug treatment, while the other half were assigned to exercise regularly. The most appropriate inference method for answering, well, we're doing two, right? Okay. And because we're not looking at an interval, we're going to do some sort of test. And because we're talking about heart rate, not like proportion or anything, we're going to be talking about mu or mean. So I would say mu1 minus mu2 is what we're looking at. So that would be a t-test. So we would say that this is a two-sample t-test. Okay, two-sample t-test for I want to make sure that's not what I have down. Hold up. Did I read that wrong? Let me read that again. I'm going kind of quick here, y'all. I'm sorry about that. I looked at the, I think it might be, so find out half the subjects are assigned to receive, while the other are assigned to exercise. How much more effective at reducing the rate of, here we go. Reducing the rate of heart attacks, not blood pressure. I was thinking blood pressure. So out of the 1,000, right? If we have 500 and 500, what proportion of these men had a heart attack based upon doing drug treatment or drug treatment and exercise, right? What was the difference there? And so because it's proportion, we'll do a 2 proportion Z test, and this would be P1 minus P2. My bad. It's important to read the actual question here. That really could throw you for a loop. So again, just be sure that make sure you go through that there. Okay. And they say is it an interval or a test? How much, let's see, how much, I don't like this. It's a little vague here. How much more effective is exercise and drug treatment than drug? I guess how much more effective is exercise and drug treatment than drug treatment alone? I don't like that first sentence because it doesn't really come out and tell you whether we're doing like a confidence interval or whether we're doing a test. How much more effective is that? I guess because how much more would be our interval. I could see us going with either B or C in either of these two contexts, okay? So I could see it either one of those two. If you have some questions on that, that's a good one to bring tomorrow as far as the test, kind of like what we did in class today. All right. Last one, researchers are interested in evaluating the effect of a natural product on reducing blood pressure. This will be done by comparing the mean reduction in blood pressure of a treatment, okay? So mean reduction. With a natural group and a placebo group using a 2-sample t-test. All right, well, it kind of gave it to you there. 2-sample t-test. The researchers would like to be able to detect whether the natural product reduces blood pressure by at least 7 points or more on average than the placebo. If groups of size 50 are used in the experiment, and I'll back up, a 2-sample t-test using a sig level of 0.01 will have a power of 80%, okay? 80% is my power with a sig level of 0.01. So remember, this is our type 1 error. Type 1 error probability, okay? And 1 minus my 0.8, that right there is my type 2. So this would be actually 0.2. So just a heads up on that. Again, type 1 is saying that we reject the null, but the null is true. And then type 2 means that we accept that the null is true, but in reality, we should have rejected it, okay? So as we look at this, if the researchers want to be able to detect a 5-point difference instead, then the power of the test would be what? Well, instead of having a 7-point difference, if I reduce this to a 5-point difference, instead, we're going to reduce this. The power of the test would then decrease, right? So if I decrease the difference on this, we know that it would decrease also the power of the test. So whatever it would be, it wouldn't be greater than. It would decrease that power, making it to where the power of this test would be less than 80%. So that's how we would attack it there. Hey, I hope this was helpful for you. I know, man, we really got after it today, and I appreciate your help and just being here. If you have any questions, if I could help you with anything else, let me know. Other than that, have a phenomenal day, and we'll get after it tomorrow. See y'all.